Welcome to Chemistry Simplified. The topic for today is neutralization reaction. In chemistry, acids and bases react together to produce salt and water, and we call this reaction a neutralization reaction. So let's say we have a generic acid, Ha, reacting with a generic base, MOH, and the end result is a salt, which in this case is Ma plus water. So as we already said, neutralization reactions produce salt and water, and this type of reaction, acid-base reactions, are common in metabolism. So let's look at an example. We got two of them, so let's see the first one. So let's say we have hydrobromic acid, which is a strong acid, reacting with barium hydroxide, which is a strong base, and the end product is a salt. In this case, the salt is barium bromide and water. So as we already said, acids and bases react together to produce salt and water. So let's balance this reaction. So we have 2 hydrobromic acid and we have 2 water molecule. We'll cover balancing reactions in future lectures. So let's work it out. So let's get the total ionic equation where we'll break down everything. Since hydrobromic acid is a strong acid, so we expect it to dissociate or ionize completely. Same thing for barium hydroxide, is a strong base, it will ionize completely. And we get the salt, which is barium ion, would dissociate because it's soluble, and bromide ion would dissociate as well because it's a soluble salt, and water. We will cover solubility of salt in future lectures. So now we have the total ionic equation. We see that bromide ion doesn't change on either side of the equation. On the reactant, we have 2 moles of bromide ion, and on the product side, on the right side, we also have 2 moles of bromide ions, meaning that we can cross it out. Likewise, we can say the same thing for barium ion. All right, it's the same thing on both sides of the equation, so we can cross it out. Now, let's get the net ionic equation. After we remove the spectator ions, we are left with 2 moles of hydrogen ion plus 2 moles of hydroxide ion to produce 2 moles of water. We can cross out the coefficient of 2 because it's everywhere, so it's not really needed. So the end product for the net ionic equation will be hydrogen ion react with hydroxide ion to produce water. And this is the end. As we've already said, neutralization reaction, acid-base reaction, produce water and the salt. So the salt is soluble, so we cancel it out, so we're left with water. And we said that bromide ion and barium ions are spectator ions, so therefore they do not participate. Just like when you go to a sporting event, you're a spectator, you're just sitting in the stand. So the same thing here, these 2 ions are spectators. Let's look at one last example. We have hydrocyanic acid, which is a weak acid, plus sodium hydroxide, which is a strong base, and the end product is sodium cyanide, the salt, plus water. Now, since hydrocyanic acid is a weak acid, it does not dissociate much. So when we write the total ionic equation, as we already seen when we looked at the weak acid, we do not expect hydrocyanic acid to dissociate, so it remains the same. But sodium hydroxide is a strong base, so we expect it to ionize to produce sodium ion and hydroxide ion. And the salt is also soluble, so it ionizes plus water. Nice. Sodium is a spectator ion because it's the same on both sides of the equation. On the reactant side it's the same, and on the product side it's the same, so we can cross it out. Nothing else is the same, so we move forward to write the net ionic equation. Hydrocyanic acid plus hydroxide ion to give us cyanide ion plus water. And this is the final equation. Sodium ion is a spectator ion because it does not participate in the reaction. This is the end of our presentation. We hope you found it useful. Please remember to like, subscribe, and share. Thank you.